Hi, my name's James King. I'm an engineer on the .NET team, and for the last couple of years I've been looking at gRPC and making it a first-class remote procedure call framework on .NET Core and .NET 5. So, our agenda for today. First I'm going to introduce gRPC. I'm going to pay particular close attention to Protobuf, which I think is a new concept to many developers. We're going to do a demo of gRPC and show how it works within the .NET ecosystem. I'm going to compare gRPC.NET with gRPC Core. There are actually two implementations of gRPC for .NET that are available. I'm going to talk through what the differences are between them. We're going to look at performance. Performance is a item of key interest to a lot of developers who are trying out gRPC. And gRPC provides great performance for your APIs. We're going to look at what's new in .NET 5 for gRPC. This is our second major release. gRPC first came out for .NET Core 3, and now on .NET 5 we have a lot of new features. And finally, we'll go over some resources that are available for developers who are interested in learning more about gRPC. So, what is gRPC? It's a popular remote procedure call framework. So there are many remote procedure call frameworks out there. WCF is one example. There's also Thrift and many other open source alternatives. But we've really noticed that the developers are coalescing around gRPC as their remote procedure call framework of choice. And that's why the .NET team has invested in making it a great experience on .NET Core and .NET 5. gRPC is run by the Cloud Native Computing Foundation, the CNCF. And what the .NET team has done is we've written a new implementation of gRPC and we've contributed it to the CNCF. So we are working with the gRPC team to make a great gRPC experience on .NET. gRPC is not new. It was originally open sourced in 2015, but it's built with modern technologies. It's really the union of HTTP2 as the underlying transport protocol and Protobuf as its contract language and its serialization technology. gRPC is designed for modern applications, particularly microservices. It's very high performance. HTTP2 includes a number of performance benefits over HTTP1, and Protobuf is a binary serialization technology. It produces very small messages, and message payloads sent between your clients and your servers should be much smaller than text-based JSON. gRPC is also platform independent. Don't think of gRPC as a single framework. Think of it more like a standard, and then there are implementations for different languages for the gRPC standard. So that means you can have a gRPC server written in .NET and you can call it from Go or Node or C++, Python, Ruby, Rust, any language you can think of. All these implementations are completely interoperable. There is a set of unit tests which are used to maintain compatibility between all the different implementations, and the implementations for .NET are part of that. So if you're using .NET and gRPC, you shouldn't have any worries about calling other implementations, other languages using gRPC frameworks. Let's pay particular close attention to Protobuf. Protobuf actually serves a number of purposes within the gRPC ecosystem. The first is acts as the IDL, the interface definition language of gRPC. So gRPC, it's a contract-first remote procedure call technology. So the first thing you tend to do with gRPC is you define your messages and your services, and you do that in a proto file using Protobuf. So here we can see we're defining two messages. We've got a request, and which has a property on it called topic. It is of type string, so Protobuf is strongly typed. And also it has this 1, so topic equals 1. That 1 is the internal identifier for this property. One of the ways that Protobuf is able to send very small payloads between the client and the server is rather than send the topic name with every message, it just sends that internal identifier. Next we can see we've got an event message, and this now has two properties on it which have different IDs and different types. Protobuf also acts as the service model, so that defines the services that your gRPC server implements and also the methods on them. So think here we can see we've got a topics service and we've got a subscribe method, and that subscribe method takes the request object that we've specified earlier, the request, and then it returns a stream of events. Think of a gRPC service like a controller in MVC, and think of the subscribe method like an action. Finally, Protobuf is the actual serialized payload. So when you are working with Protobuf protofiles, they will tend to generate messages for you with code generation. You can then create them within your program, and then when you give them to gRPC, they're automatically serialized to the Protobuf wire format. And this is the wire format that is sent between the client and the server and then back again. So interesting to note about this compared to JSON is Protobuf is very small. It's a binary serialization technology, which means it's much smaller than text-based JSON. I think a lot of developers are very familiar with RESTful HTTP APIs, but gRPC, it's a new concept. A good way to introduce it is to compare it against REST. So the first difference is gRPC, it is a opinionated contract-first RPC framework, and that contract is the protofile. That's what we just saw earlier, where you define your messages, you define your services. gRPC then takes that file and will generate types for you. So it will generate the messages for you, it will generate you a service-based type to implement on the server, and it will generate you a strongly typed client that is very easily able to invoke gRPC services. So if we compare that with RESTful APIs, with RESTful APIs you tend to worry about the content first and write code to produce that content. So you'll be building up, if you're working within the context of .NET and MVC, you'll be creating controllers, you'll be creating actions, you'll be creating types that are bound to and then return from those methods. You're worrying about URLs and HTTP methods and what the JSON will look like. You tend to write that first with code, and then only afterwards, as an optional step, might you produce a Swagger file as a contract for that. Compare that with gRPC, that proto file is the first thing you would write. With gRPC, the contract is designed for humans. So that proto file we saw earlier, that's very easy to read and write and modify. It's designed for humans to interact with. If we compare that with HTTP APIs, it's the content which is designed for humans. So when you're sending a JSON message between two computers with an HTTP 1.1 call, it's very easy for you to read and debug and understand that. But it's not optimized for computers at runtime. It's slower to produce than a binary message using Protobuf. So Protobuf and gRPC, that contract is designed for humans, but the actual runtime messages, they're optimized for speed and performance. And that's part of why gRPC is able to achieve higher performance than RESTful APIs. gRPC is designed to hide the complexity of remoting. So the code that is generated for you from a proto file, both on the server and the client, it will handle all serialization for you, it will handle routing for you, building up URLs for you. Meanwhile, HTTP and REST, it tends to emphasize HTTP more. You can do whatever you want within the context of the HTTP standard, but that means they're more complex, there's more options for choice, so you can choose how you want to format a URL. You can choose how you want to send back HTTP headers, how you do routing, all those kind of things. But that great choice means it's a little more difficult to streamline and optimize things. So the great thing about gRPC, because you've just got that proto file, gRPC understands everything about how to invoke the call on the server. So it's able to generate you a strongly typed client that is able to hide away all the complexity of remoting. Calling a gRPC service with a client is just as hard, just as simple as invoking any other async method. You're just calling a method and you're giving it a Protobuf message and gRPC, and the client will handle all the rest. So if I was going to sum up these two approaches, gRPC, it focuses on performance and it focuses on developer productivity. Meanwhile, HTTP APIs, they focus on the widest audience. Every platform and language is able to support HTTP 1.1 and JSON, so REST should work from anywhere. It's able to be called from anywhere. REST is also very easy to get started. gRPC, there's a little bit of work at the start to set up the code generation. Like, it's not difficult, but it is more work than REST. Meanwhile, REST, you can easily call a RESTful service just by writing a few lines of JSON. Okay, so now that we've introduced gRPC, let's do a demo of using it in action. So first thing we're going to want to do is to create a gRPC service that will act as our server. And what's included with .NET Framework, .NET Core, is we've included a template. So if you type in gRPC up here when creating a new project, you'll get a gRPC service. So this gRPC service will create an ASP.NET Core website with gRPC set up and ready to go. So we're using .NET 5, let's click Create. We're creating our new project. And once Visual Studio is open, let's take a look around and see what's been created for us. So, first thing we can see is we have this protos directory. And in this protos directory we have greet.proto. So this is the proto file contract that I've been talking about. Here we've got a greeter service, which has a say hello method. It takes a request, which we can see defined down here, which has a name, and it returns a reply, which has a message. So this is basically hello world. We're specifying a name, and then the server will return a message replying to that name. So what does it look like from this proto file to actually implement the service in C#? So under our services folder, we have a greeter service, and it has a say hello method. So we're taking our request, that hello request object, and then we're returning hello reply, and we're just reading the name off the request and we're setting it onto the message that we're returning. So it's pretty simple. But what jumps out to me immediately is, where are these types coming from? Where is hello request coming from? Where is hello reply coming from? What is this greeter base? So this is the code generation I talked about. This greet.proto file is being used to drive code generation, which is generating these types. And if we go back to our service and we choose our request object and we F12 into it, we've got a whole bunch of generated code. And where is this generated code sitting? If we click to show all files, we get some hidden directories. And if we navigate into these hidden directories, we can see we have our generated code sitting under this object directory. So I like to think of generated code as there being good generated code and bad generated code. The bad kind is code you need to worry about. You need to generate it yourself, you need to check it into source control, you need to worry about someone coming along and checking it out and modifying it and checking it back in and everything going out of sync because they didn't do it properly. Good generated code, it just happens for you. You don't need to think about it. This code is hidden away because you shouldn't need to think about it. Like writing all of this and how all of this works, this is stuff that we do for you to make gRPC very easy to use. So sitting in that hidden directory, we have our generated code. And on that, in our greeter base file, we can see we've got our say hello method. It's a virtual method, so all we need to do when we're implementing a new gRPC service is we just override it and then write our new implementation. So let me just compile this to make sure everything's working correctly. So build succeeded. Let's run this. So let me get the path to it. So we're building our new gRPC service, and Kestrel's now launched and it's now available on these addresses. So let's open up our gRPC service and see what happens when we visit it in a browser. So we don't get a hello world response. Instead we get this message: communication with gRPC endpoints must be made through a gRPC client. So the reason we get this message is because gRPC, it's not like REST where you can just navigate in a browser and type in a URL and hit a get endpoint and get a result. gRPC, both the client and the server, need to know about that contract. It's a contract first RPC framework, both from a perspective of a client and the perspective of a server. So what we need to do is we need to create a gRPC client that knows about that protofile. And the way we will do that is we will create a new project in Visual Studio. So what we'll do is we'll create a new console app with .NET Core. Click Create. And let me just come into our project file. We'll make this .NET 5 as well. So we need to add to our console app the NuGet packages and the protofile to be able to successfully call our gRPC service. If we take a look in our server, we can see we've got a reference to that greet.protofile. The reason we have this reference to the protofile, which is located here, is we need to be able to do code generation for it, and code generation happens automatically whenever an app is compiled. And by adding in this greet.protofile with this Protobuf element, we tell the compiler this is a Protobuf file, you should do code generation for it. And then we have this attribute on it to say we want to do server generation. So we want to generate this greeter base type that acts as the base type for our service. We don't want to generate a strongly typed client. Generating a strongly typed client is what we want to do in our new console app. So there are a couple of options here for adding the NuGet packages and the protofile to this CS proj. We could do it manually. What we've done in Visual Studio though is we've added a new UI option called Add Connected Service, and when you choose Add Connected Service you get the option to add a service reference. So we want to add a service reference to our protofile. So we'll choose gRPC. We will then browse in Visual Studio to our new service and we'll choose that greet.protofile. We'll click OK. Now we'll be asked what kind of code generation do we want. Do we want it to be for the client? Do we want it to be for the server? Or do we want it to be for both? In this case, it's already chosen client, which is what we want. So we'll click Finish. And a bunch of things will happen. Visual Studio is adding NuGet packages for us, and it's added the greet.proto to the project. So if we click Close, we can see we now have our service reference here. We now have this protos folder in our client app, and if we look at the CS proj file, the C# project file, we've got a bunch of new lines of XML in here. We're now referencing our NuGet packages for gRPC, and we're also referencing our greet.proto file, and we have the Protobuf element. Note that gRPC services, instead of saying server, it now says client. So let's just compile this to make sure everything is working correctly so far. Okay, so we've now set up code generation in our client. Now let's use our new client. So what I'll do is I've got some snippets here to quickly add the necessary code. So first thing we'll do is we'll add a channel. So a gRPC channel represents the connection between the client and the server. So here we specify the address that our server is running on. So we can see that over here. And once we have a channel, we then want to create the strongly typed client. So this is what was generated for us from code generation. So we just need to add the namespace, and now we have our strongly typed client. So using our client, let's call our service. So we're awaiting, so let's just make our method async. So with our client, we're just calling say hello async. This is a strongly typed method which takes our hello request and then it's returning a hello reply. And finally, with our response, let's write it out to the console. So if everything has gone to plan, let's compile that. That's succeeded. Let's restart our server just to reduce the amount of logging on the screen. And let's browse to our client. And run it. And if everything has gone to plan, you should see hello.net. And over here on the server, we can see our call has come in to Kestrel. So we've got an HTTP2 call with it's a post, so all gRPC calls are posts. This URL was automatically set for us by the gRPC client. This is a standard gRPC URL. And it's also set the content type. And here we can see the server has mapped the incoming URL to our gRPC service endpoint, and it has invoked say hello, and that's then completed, which has then returned our result to the client. So everything has worked perfectly. Let's just stop both of these. Okay, so what we've seen just now, say hello, is a basic gRPC unary call. So gRPC, as well as supporting unary calls, which are a single request object followed by a single response object, gRPC also supports something called streaming. So with streaming, you're able to return multiple calls, messages from a server, or send multiple messages to the server, both of those over time, so in a streaming fashion. This is something which is very difficult to do with REST and usually isn't done, but with gRPC it's very simple. So let's add a new streaming call to our service. So I'll call this say hello stream, and we'll still send a single request, but now let's return a stream of replies. And the way you do that is you just specify stream here. If we wanted to stream in both directions, we could specify stream with our request, but in this case we're just going to stream back from the server. This is called server streaming. Okay, now we've done that, code generation should have automatically added our new virtual method, which we override here. And now we have our say hello stream method. So at the moment we're not doing anything, let's just add an implementation. Something else to note, the method signature for our unary call, our say hello call, is different from our streaming call. Our streaming call has the stream writer, and that's because we want to return messages over time. Compare that with our say hello call, where we're just returning a single hello reply. Okay, so in our new call, let's return 10 messages. And the way we'll do that is we have our response writer, our response stream, and we'll write a new reply, and we'll do exactly what our other method does. We'll say hello to our request name, and we'll make it slightly different. Let's include the number. Now this is an async call, so we'll need to make this method async. And because this will run really fast, we want to see our streaming over a period of time. So let's add in a task.delay. And we'll make our delay of 1 second. Okay, I think that looks good. Now we need to call our streaming call from the client. So what we'll do here is, let's modify this slightly. As well as our previous say hello call, now we have an option for say hello stream. And to say hello stream, we'll pass in the same message, same request. And this is slightly different. We're not awaiting this because we're not getting back a single message. Instead we're getting back a call, and on our call we're going to have a response stream. So response stream is a stream of messages coming back from the server, and the way we're going to read this is with an await for each. So await for each is just like a regular for each, except it doesn't block while it's waiting for a new message. So we've got that 1 second delay. During that 1 second delay, if this was a UI app like Blazor or WPF, the UI wouldn't hang because we're awaiting, we're giving back the thread to either the client, or if we're on the server, to the server, so that thread can be used for something else. And let's do exactly what we did before. Let's write to the console with the result of our gRPC call message. And I think we're done. Okay, so let's clear all this away. Let's do another .NET run on our server. And that's built, and now let's run our client. So if everything has gone to plan, our call has started. So we're now getting back results streamed from the server. That number is slowly incrementing. We can see our call has started over here. And as we hit number 10, our server finishes, and it returns back to the client the fact that it's finished. And when that happens, our for each call completes, and our client apps is done. So that's gRPC. Both a basic unary call and a server streaming call. It's very easy to use, and as you can see, gRPC, it hides away all the normal concerns you have around HTTP. Like, we're never worrying about routing or headers or content types or serialization. Like, the gRPC server and client code generation just handles all of that for us. So it's both extremely fast because of the performance benefits of gRPC offers, but there's also great developer productivity because of that code generation. It's doing a lot of the work for you. Okay, let's keep going. So let's go a bit deeper into what we've added to gRPC in .NET Core and .NET 5. So gRPC has actually been supported in .NET for a while. gRPC Core has existed since 2015, basically since gRPC has been around. gRPC Core, it's a .NET wrapper of a native implementation of gRPC in HTTP2. So within the gRPC.core package, there are C++ binaries which contain an HTTP server, a TLS implementation, a gRPC client, and a gRPC server. While it works, and it's worked great for a long time, there are a couple of downsides with gRPC Core. It's a bit slow, and that's just because it needs to have both a C++ implementation and then a thin .NET wrapper around it. So it's very easy for people to use from .NET. But because it has both of those components, it's a bit slower than it could be. It's also quite large. It's a large NuGet package. Because of all those native dependencies, you have both a brand new server and TLS implementation and gRPC implementations, and then they need to be multiplied by the number of platforms, because that NuGet package needs to support Windows and Linux and OS X. So what have we done in our new implementation? So we have two new NuGet packages. We have gRPC ASP.NET Core, so that's our server implementation. That sits on top of Kestrel and it integrates very well with ASP.NET Core. So you can use all your favorite ASP.NET Core features like dependency injection, configuration, you can have middleware, you can use your standard authorization or authentication options. All of those things work with our new gRPC ASP.NET Core NuGet package. We also have a new NuGet package for the client, gRPC Net Client. That sits on top of HTTP Client, which supports HTTP 2, and because you're using HTTP Client, outgoing middleware implemented via delegating handlers are also supported. So one of our goals with our new implementation is to maintain portability between gRPC Core and gRPC.NET, which are our new implementations. And the way we've done that is we've identified a common API and we've split it out from gRPC Core, and then we've made all the implementations use this common API. So that common API is stuff like that request and response stream, a channel base type. All those concepts are shared between gRPC Core and our new implementation. And that means a gRPC service or a gRPC client looks exactly the same depending upon which implementation you're using, just underneath, behind the scenes, the way they're implemented is different. Now if you're building a .NET Core or .NET 5 app, you don't really need to worry about gRPC Core. We recommend using the new implementations just because of the performance benefits and the greater integration with the rest of the .NET ecosystem. But if you're using .NET Framework, then gRPC Core is a good choice. Our new implementations don't support .NET Framework, so gRPC Core is your best option there. So a lot of people who are interested in gRPC are interested in it because of its performance. So performance is one of its key features. It gets great performance through a number of ways, and one of those is via low network usage. So HTTP 2 is a binary protocol compared to text-based HTTP 1.1. That means it's able to support things like binary framing and header compression, and just overall saving the amount of bandwidth required to make HTTP requests. The other way gRPC is able to save network usage compared to REST is its Protobuf message serialization. Protobuf is significantly smaller than JSON in most use cases. So I've got an example here of some JSON and then its Protobuf representation. Although these look about the same size, remember this is a Protobuf contract, this is the proto file. This isn't actually what is sent across the wire when a gRPC call is being made. What's been sent across the wire is a very small binary representation of the JSON data. So how is Protobuf able to save network usage compared to JSON? One way is it doesn't send those property names, it just sends a very small ID. A lot of data types are much smaller and faster to send with Protobuf compared to JSON. A floating point number might take many UTF-8 bytes to represent in JSON. Meanwhile, they're just a bit or two perhaps with Protobuf. And the same with dates and booleans and all the control characters and indenting which you typically see with JSON. You just don't have those with Protobuf. So someone in the community went out and they compared this exact JSON example to Protobuf, and they found Protobuf was between a quarter or a third the size of JSON. So it's a significant network savings. Now your mileage may vary. How much your Protobuf message is smaller than JSON will depend on exactly what kind of data you're sending. large string values, they tend to be about the same size regardless of whether you're using Protobuf or you're using JSON. They're both UTF-8 bytes, they're just sent in different ways. Another way gRPC gets its great performance is via HTTP2 multiplexing. So HTTP2 multiplexing makes more efficient use of TCP connections. You're able to, with a single TCP connection, send many requests via it and have them all happen independently. There's no head of line blocking like there was with HTTP 1.1. So a canonical example of showing this in action is if you're within a browser and you take one large image and you split it up into 100 smaller images. With HTTP 1.1, only a few can be downloaded simultaneously via a browser because it can only make a couple of TCP connections to a server. Meanwhile, HTTP 2, they're downloaded almost simultaneously, and so the end result is your data comes back much faster. So another interesting feature of gRPC is streaming. I showed you that earlier with the demo. There are a number of different kinds of streaming with gRPC. So first we had our basic unary call. That was our say hello method. We sent a single request and we got a single reply. Server streaming, that was when we sent a single request and we got back 10 replies. That number can be as many as we want. An example of server streaming might be you have a client that wants to subscribe to weather updates from a server. So the client could initiate a server streaming call to the server, and then the server, as weather updates, it can stream back responses in real time. So as soon as the server has it, it can send it back to the client, and the client is instantly notified. So gRPC is a very easy way to create real-time services without you having to use something like polling. Client streaming, that's just the opposite of server streaming. So an example of where that might be useful, imagine you want to send a lot of data to a server and you want to split it up into many smaller messages. You could stream those smaller messages to the server, and then once you're complete, the server sends you back a reply indicating whether all of those messages were successfully received. And finally, bidirectional streaming. That's just streaming in both directions simultaneously. An example of where that might be useful is perhaps you want to have a chat room and you want to have a client both be able to send chat messages and receive chat messages at the same time. So gRPC on .NET Core, our first release was in .NET Core 3. Now with .NET 5 we have a bunch of new features which I think will be very useful for developers. The first one is gRPC Web. So gRPC typically isn't usable via a browser, and that's just because the HTTP client sitting within a browser, so the fetch method with JSON and also XHR, they don't support all of the necessary HTTP2 features required to be able to successfully make a gRPC call. Now what gRPC Web does is it modifies the gRPC standard slightly and the way it sends data across the wire so that a browser is able to send and receive gRPC messages. So gRPC Web, it sacrifices a little bit of performance, just a tiny bit, so that gRPC is usable from a browser, and even though you do sacrifice a little bit, you still get all the benefits of the very small Protobuf messages. So if you have an app, a browser app, where you want to reduce the amount of network usage between the client and the server, gRPC Web and those Protobuf messages are still a good choice. gRPC and ASP.NET Core now supports being hosted in Kestrel, HTTPsys and IIS. So Kestrel was what was available in .NET Core 3. Now with .NET 5 we also support HTTPsys and IIS on Windows servers. Keep Alive pings are a new feature in .NET 5. Keep Alive pings have a number of interesting uses. They can be used to keep connections alive from clients that want to have really fast, high-performance calls to the server. You want to keep a connection alive because there's a bit of overhead in establishing a connection. The client needs to establish a TCP connection with the server, it then needs to negotiate TLS, then needs to negotiate an HTTP2 connection, and finally it needs to make a call. If you have a connection already and warm and kept alive with a keep alive ping, then all you need to do is make the call, and gRPC is much faster. Inter-process communication is now supported with gRPC and .NET 5. So if you have two processes sitting on the same computer and you want to communicate between them, you could use gRPC in .NET Core 3 and have them communicate over TCP, but TCP is overkill when you're on the same computer. Inter-process communication technologies like Unix domain sockets or named pipes are a more efficient alternative, and they are now supported with gRPC. And performance. Performance has been a very big focus for us with .NET 5. And you can see here with this graph us overtaking Golang. This happened back in April. Since then we've made many more performance improvements, and gRPC on .NET 5 has just continued to improve in performance. So some of the performance related features we've added: HPAC header compression with responses from Kestrel are now supported. The amount of data, amount of memory allocated to handle a gRPC request has decreased by 92% in .NET 5 compared to .NET Core 3. The server requests per second, or overall throughput, has increased by 60%. So here on this graph you can see we were hovering around 0.4 million when we started. Now it's up to 0.75 million, so a big boost. Client requests per second has increased by 230%. So there were some concurrency issues with the client in .NET Core 3. They've now been resolved with .NET 5, and the client is significantly faster. And finally, we've been working with the team at Google to improve their Protobuf serializer so that it is able to support high performance memory options and serialization using span of T and iBuffer writer and read-only sequence of T. And those really reduce the allocations related to Protobuf serialization. And if we look at a community benchmark of different gRPC implementations on different platforms, here we can see gRPC.NET is the second fastest, coming only after Rust. So we're hanging around the top with other fast implementations like C++, Go, Rust, and obviously gRPC on .NET. If you're interested in using gRPC, let's talk about some of the resources that are available. We've spent a lot of time investing in documentation, and that's available on docs.microsoft.com. Here you can just see just a brief summary of the many articles that are now available. If you're interested in learning more about gRPC, I recommend going here as the first place to learn more. We've also written a lot of basic examples. Each example shows one or two core concepts in action. So for example, how to do streaming, or perhaps how to do authentication using a certificate or a JOT token, or how to do unit testing using gRPC services. And you can find all of these samples at our GitHub repo. So that's all I have for you today about gRPC. I hope everyone's learned a lot and you're interested in trying out gRPC and learning more. Thank you very much.